Hello, I'm Phil McCaffrey, and this is 8:30 Prep. It's an experiment that I'm trying with Damien. So say hello, Damien.
Hello.
Damien is our video producer, and we're in our studios here at 1400 Church Street, the home of 3-Hour Prep. So the SAT is on Saturday. I thought I'd focus exclusively on the number one problem on the SAT, which is linear functions. And the SAT loves to ask linear functions. I haven't done a review lately, but my initial review of the SAT out of 58 problems is that there's about 10 or 11 that are just linear functions. So I snagged a couple of them that are a nice cross-representation of how the SAT asks the questions. And as you're going to see, they're relatively easy. So what I'm going to do is read the questions out loud to you and solve them and show you what to look for on Saturday as you take the SAT. So the first one is off of the blue book. It's test number 7. These were all given SATs. So this is all real material that they've put out since 2016. Some of them I've copied off of nebulous sources that will go unnamed. Reddit. So test number 1. Question number 1 is off of test number 7, and it gives an equation. Y is equal to 19.99 plus 1.50x. This is just absolutely nuts because there is no algebra teacher or science teacher in the world that would not write this equation, y equals mx plus b. But what the SAT loves to do is they love to write y equals b plus mx. If you'll remember from elementary school, this is called the commutative property, and that is a plus b is equal to b plus a. 2 plus 3 is 5. 3 plus 2 is 5. They switch them around. The only reason they're doing this is to mess with teenagers. There's absolutely no reason to do this. Algebra is the most universal language in the world. This terminology, these symbols, were all codified by the Germans well over 150 to 140 years ago, and algebra was put in concrete. Codified means written down. So y equals mx plus b is actually written in the German language, as we'll see when I do a lesson on direct variation. So the question asks, the equation above models the total cost y in dollars that a company charges a customer to rent a truck for one day and drive the truck X miles. The total cost consists of a flat fee plus a charge per mile. Phil's rule number 1 is read with your pencil. And that is underline keywords. As you're reading the SAT on Saturday, I hope you're one of the students who are taking it on a booklet and not on a computer. Read along. If you're right-handed like I am, put your left finger on the question and read along with your pencil. The key word here is flat fee. The SAT loves this word, and you're going to see it again. And then a charge per mile. When we're talking linear functions, per is the most important word. That's the word that means slope. So the slope of this equation is 1.5x plus 19.99. The question asks, what does the y-intercept of the graph represent in the model? Well, it represents the flat fee of $19.99. So this is our B, this is our M, and this is our X. It represents the y-intercept represents the flat fee. So when you hire a plumber or somebody like that to come to your house, you pay them an amount to show up, so no matter what work, and then an amount per hour. So it starts off at the y-intercept. Here is one straight off of an unknown year that I'm not going to say, but was given during the time period of April. It was actually off of a test, I believe, given in Maine, where they required the SAT to produce the test in a PDF format. So, of course, all of us tutors are out there looking for this stuff online. It said the boiling point of water at sea level is 212 degrees Fahrenheit. For every increase of 1,000 feet above sea level, the boiling point of water drops approximately 1.84 degrees Fahrenheit. Which of the following equations gives the approximate boiling point in degrees Fahrenheit at h feet above sea level? Notice once again, what do we have? We have b plus mx, b minus mx. This one is direct variation. And then we actually have put in here b equals 1.8 times 2.2 minus this. This is once again some really weird. That one's just so weird it's not even a linear function. How do we know that it's a linear function? It drops for every, here's our keyword. So the last one was charge per mile. This one is for every. So another great word to know is for every and for each. For every and for each almost always means your slope. So for every increase of 1,000 feet, it drops 1.8 degrees. Well, let's put in 1,000 feet. H as the x variable, 1,000 feet is what they give us, so let's put in 1,000. So at the boiling is 212 degrees, 1.8 times 1,000 is 1,840. I don't think we're going to be 1,840 degrees below zero. So the answer choice A is completely wrong. 212 minus 0.0018. Let's put in 1,000. And when we put in 1,000, we multiply and move the decimal place 3 places. Oh, look at that. 1.84 degrees. And that is 212 minus 1.84. That's our answer. 212 times 1,000, 200,000 degrees. That's like melting the sun. And 1.84 times 212 minus 1,000 times 1,000, that's really, really cold. I think that's probably below absolute zero, but I should know what absolute zero. What's absolute zero, Damien?
You're asking the wrong guy.
I'm asking the wrong guy. I should have thought of that beforehand. All right. Off of a May QAS. QAS stands for Question and Answer Service. This is the booklet that the SAT allows students to buy. They used to produce it on paper, which is why I have such nice copies of it. They now only produce it online, so students get to see their questions in October, March, and May. If you go to the subreddit, r SAT, on the website Reddit and type in QAS, you'll get to see some links to some tests. It's a very good thing to study if you're going to study for the work. All right, here we go. Ready? For each repair job, an elevator technician charges $R per hour. When we have a per, that's our slope. And for each hour worked plus a flat fee. We've seen this before. So we have Y equals $R times the amount of hours put in plus the flat fee. If the so the flat fee is K dollars. This technician is going to charge $210. So we want for how many hours? 2. So we want 2 times R plus K. Try to figure out the equation before you look at the answer choices. But if you get stuck, use the answer choices. So what are we looking for? 2R plus K, which they wrote backwards. So my big tip for tonight, look for them writing a linear function backwards on Saturday. This is 2 times the flat rate plus the slope. This is 2 times the slope minus the flat rate. No repair technician is going to take off their flat rate. It's a subtraction. And this one is the slope minus 2 times the flat rate. So they try to do every possible way you can get it wrong, and it looks really confusing. So just remember to write it as y equals mx plus b. What's b? Flat fee. What is rate? Per hour. Slope is our rate. All right, let's move on. Question number 4. What do we have again? A backwards linear function. Notice what I'm doing tonight. I'm teaching backwards linear function, and it says an airplane flies directly from a city in Pennsylvania to a city in Ecuador. This definitely has to be Philadelphia because there's no direct flights out of Pittsburgh to anywhere. The equation above estimates the distance d. Did anybody say anything? Oh, sorry, I got distracted for a second. Squirrel. The equation above estimates the distance d in miles from the city in Ecuador, from the city in Ecuador of the airplane t hours after taking off from the city in Pennsylvania. Let's draw a graph. So I have y equals mx plus b, and this is absolutely my y-intercept. So I'm 2,565 miles. I'm flying down to land in Ecuador, which is 0 miles, and my rate of change is 500 miles an hour. So this is minus 500 times my time. So what is my equation? Y equals negative 500 times the time plus 2,565. I can't speak tonight. Let's change the color. Which of the following is the best interpretation of the number 2,565? Since y is distance, this is be h of t, or distance, d of t I could call it. What does it represent? It represents the speed, a, in miles per hour, b, the distance in miles that the airplane travels in 1 hour. It's flying at 500 miles an hour, so that's not right. And it's certainly not the speed. An airplane flying at 2,500 miles an hour from a city in Pennsylvania is going to be a really fast airplane. The distance in miles the airplane travels between the two cities. The distance between the two cities given over the time t. And lastly, the time t in minutes. Where'd that come from? That's just ridiculous. There's nothing mentioned about minutes at all in this equation. And if we divided 2,565 by 500, we wouldn't get anywhere near 2,000 minutes. Okay, from another test given in May, it's a QAS. Oh, all of a sudden, we have a function in linear form where we have y is equal to mx plus b. But notice they use function form. A lot of students are afraid of function form. Don't be afraid of function form. The German mathematician Euler came up with it to save ink. So we can thank him very much for torturing students. This one says an archaeologist estimates that as the result of erosion, the height of the Great Pyramid of Giza has been decreasing at a constant rate. The reason I picked this problem is because it said constant rate. Constant rate always means y equals mx plus b. And what is the constant rate? Your slope. What is the b? This is the starting point. So it's going down negative, so there's a starting point. So the Great Pyramid of Giza at some point must have been 481 feet. And it is decreasing at a very slow rate. The function above is used by the archaeologist to model the height and feet of the pyramid t years after it was built. According to the function, which of the following statements is true? Every 1,750 years, the height of the pyramid decreases by 10 feet. So let's put in 1,750 years in for t. So I'll take 1,750 years. I'll divide that by 175. Well, 175.50 divided by 175 gives me 10. And that decreases 10 feet. That looks pretty good. Every 175 years, the height of the pyramid decreases by 0.1 foot. So 175 divided by 175 is not 0.1. That's 1 foot. So that's wrong. Every 100 years, the height of the pyramid decreases by 1.75 feet. This doesn't even make sense since the pyramids are thousands of years old. If every 100 years it went down 2 feet, it would be absolutely zero. That doesn't even make sense. And every year the height of the pyramid decreases by 175 feet. I mean, this thing would just be falling right into the sand. The right answer choice is A. I will post a PDF of this. I'm sorry that I didn't beforehand so you could download it. All right, we've got 7 questions today, 6 to go. And I've saved some of the best for last, which is a graph. The function h, defined by h equals at plus b, look, we have slope-intercept form, where a and b are constants, models the height in centimeters of a sunflower t days of growth during a time period in which the growth is approximately linear. Well, where is it approximately linear? That's about right there. What does A represent? Since this is given in slope-intercept form, A represents the change in y over the change in x. Well, what's y? Height in centimeters. What's x? Days. So this is the change in the height of the sunflower over the days. A is the predicted number of centimeters the sunflower grows each day during the period. Now, that sounds pretty good. The predicted height in centimeters of the sunflower at the beginning of the period. At the beginning of the period would be our y-intercept, which is about 60. That doesn't make any sense because that's b up here at at plus b, so that's wrong. The predicted height in centimeters of the sunflower at the end of the period. That would have to be given b, put in a and no t. That's wrong. It doesn't give us enough because a represents our slope, our change. The predicted total increase of the height during the period. The predicted total increase. That's the function. The answer is the predicted number of centimeters the sunflower grows each day. Each day. The key to this one is each day. And we're not done so bad on time. I was afraid this was going to cost me about 35 minutes. Lastly, SAT number 9. This is available online on the SAT. It's a scatter plot with a expected value. So what do we have? I'd like to read the y values and the x value. The minimum wage, dollars per hour, in the years since 1940. Years matter. It says years since 1940. It gives decades, but these are just marks on here. It also includes the years in between, but it's only marking out what is done like during a census. The scatter plot above shows the federal mandated minimum wage every 10 years between 1940 and 2010. A line of best fit is shown is in the equation y equals 0.096x m times my input x minus 0.488. What does the line of best fit predict about the increase in minimum wage over the 70-year period? What is increase? A positive slope. It's going to increase 0.096 per x. What's x? Years. Well, let's see if any of my answer choices matches 0.96 for every year or each year. It doesn't say decades. The one thing down here is every 10 years. That would be decades since 1940. Each year, every 10 years, every 10 years. C and D are wrong. Each year between 1940 and 1910, the average increase in minimum wage was our slope. Each year between 1940 and 1910, the average increase in minimum wage, I keep looking at the chat. Nobody's saying something, but the chat says say something. So I keep looking at that and thinking that somebody is saying say something to me. All right, let me go back to this. Each year between 1940 and 2010, the average increase in minimum wage was $0.49. Well, that is my y-intercept, so it's clearly wrong. The answer is each year. Notice the key words. Let's go through these really, really quickly. I want to hit the key words. Flat fee per. For every, for each. Per hour, flat fee. Miles per hour. Where's the per in this one? Miles, in miles for the t hours after taking off. This is miles per hour. It is distance. This is distance equals rate times time. A very good thing to know. It comes up quite a bit. And here we have a great slope-intercept form. Constant rate, one of my favorite ones. Write that one down, constant rate. Linear function, y is the slope is the change in y over the change in x. Always pay attention to your y and x. This is particularly important on any graph. And lastly, the change in y over the change in x, the minimum wage for each year. And that's the lesson on linear functions for the SAT. Good luck on Saturday. I'm Phil at 3R Prep. If you have any questions, I'll try to get to you. I'll try to get you some answers. I'd be happy if somebody sent me some. Thanks.